Okay, dear students, now let's proceed to the next one. It says express the following decimal numbers in the form of fractions. So as usual, you will be given a certain decimal number, like 23.425. Here, the repeated digits are 2 and 5. So we do have P to be 2 because P represents the number of digits. So we are having 2 digits here, 2 and 5. So P is 2. And after the decimal, we have 1 digit without being repeated. So our K is what? 1, because 4 is not, as you see, being repeated. So for number 4, we do have K to be 1. For number 4, we do have K to be 1. And here P will be 2 because number of digits, you see, that are repeated here are 2, as you see, 2 and 5. So our K is 1 and PE is 2. So as usual, we need to apply the formula and determine the equivalent fraction form for this decimal number. So we need to treat D to be this one, the decimal D is this one, and next from this, using the formula, D is equal to D times 10 to the power of K plus P minus 10 to the power of K over 10 to the power of K plus P minus 10 to the power of K. We knew what K and P are. K is 1 and P is 2, as I said earlier. So this is going to be 23.425, having a bar on 2 and 5, times 10 to the power of K is 1 and P is 2. Directly substitute that. Minus 10 to the power of 1 can come. And this makes 1000, guys. This makes 1000, and this is 10. And this is again 1000 minus 10. Basically, this is going to be 990, right? 990. So we have this directly from this one. As I tried to explain previously, we must not perform this difference first. Doing that will never help us to find the intended fraction form. So what we need to do is we need to multiply this one by 1000 first and then by 10, just apply the split property. But for the denominator, we can take, you see, 990 directly. So what follows from this is this one, look. 990 comes because of the difference here, 1010, 990. Now here, there is one thing that I would like to tell you, and that is, look, this number, you see, is 23.425 having bars on 2 and 5. What do you mean by saying that? This means 23.4252525. These two digits, 2 and 5, are repeating throughout to the right side. So what we need to do when we multiply with 1000 is you need to move these decimal points 3 digits to the right. It's passing through 3 digits to the right. So move 1, you see, passing through 1 digit. Look, here comes another one, you see, and the last one here. So the point comes out, you see, being over here. Don't forget that this 25 is existing throughout. So this is going to be 23,425.252525 because this is being repeated. So as you are multiplying this by 1000, this is going to be 23,425 minus, 0.25 repeating. What about as you are multiplying by 10? Look, as you are multiplying by 10, you need to move this decimal point to the right by 1 unit. Reason, passing through 1 digit. Reason, because we are multiplying this by 10. You see, here in 10 we do have 1 0. The number of, you see, the number of digits you need to pass through, you see, as you are moving to the right depends on the number of zeros you are having here. So as you are moving this decimal point, you see 1 passing through 1 digit to the right side, this turns to be 234.25 having bar 2525 like that. So this is going to be like this then. Look, as you are doing that, 23,425.25 repeating minus 234.25 repeating divided by 990 can come. Look, dear students, here. The numerator is written in such a way that subtraction can easily be performed. We can directly eliminate 2525 here. See, those digits after the decimal are arranged in such a way that you see their difference can be 0, no problem. So finally, what's going to follow is 23,425 minus 234 divided by 990. It is so simple to find the difference of these two, matter of being grade 2. So this will be 2091. You see, 91 divided by 990 can come. So beloved ones, so this decimal number is equivalent to this fraction, as you see. Now, is there another shortcut technique in order to perform this one without applying the formula? Yes, there is. The idea goes like this. Take the given digit to be x, or consider this to be x. You may also consider it no problem. So have that to be x. You see, just to make it different from the previous one. And then look, what you need to do is you have to watch the number of digits after the decimal. How many digits do you have without being repeated after the decimal? Only one, and that is number 4. So you need to multiply by this 10. By 10. Reason? Because we are having only one digit here. Had you have, for instance, 2 digits, this would have been multiplied by 100. You see, had you have, for instance, 3 digits without being repeated after the decimal, you could have multiplied this by 1002. Anyway, for the time being, we are having only one digit after the decimal without being repeated, that is 4, so let's multiply this by 10. So as you are multiplying this by 10, look, this point will move 1 unit to the right, and it's going to be 234.25 repeating. Now look, students, our intention is to obtain a certain fraction without having, you see, a repetition form or having a bar over it. So to do that, look, we need to again move this decimal, you see, to the right, passing through 3 digits. And for that to come, we need to multiply this by what? 1000. Reason? In 1000, we do have 3 zeros. So this point now moves, you see, 3 to the right, passing through these 3 digits. And what will happen? 23,425.25 having a bar over them can come. And it will be like this. 1000x equals, look, 23,425.25 having a bar. So look, direct now difference can be obtained. If you directly subtract these two, you see, the two can cancel each other. Those, you see, digits after the decimal can cancel each other because they're identical. And instead of taking the difference, you see, downward, let's have, you see, the difference to be upward, just to eliminate negative expression. So 1000x minus 10x is going to be 990x, okay? And 23,425, you see, minus 231 makes 2000, what, student? 2091. So our intention is to find the equivalent expression for this equivalent fraction form for this x. So let's divide the whole by 990 in order to obtain x alone. So as you are dividing that, you see 2091 divided by 990 can come. Now, dear students, what have you obtained? You obtained the equivalent fraction form for this decimal number. Hence, the 23.425 repeating has such fraction, 2091 over 990. Up next is another question, guys. It says, show that radical 2 is irrational. For this, I'm going to apply proof by contradiction, students. So what we need to do is, at the beginning, we will accept or we assume that radical 2 is irrational. Basically, radical 2 is irrational, as you all know. But let's assume here, for the time being, as you see, root 2, rational 1. What I'm going to do is, applying this assumption, I am going to perform certain mathematical operations, and I will come to certain wrong mathematical statements, and by recreating, we will just come back and say that radical 2 is irrational. That is the way, you see, the proof by contradiction applies. So let's proceed. Suppose radical 2 is irrational. Actually, this is wrong, but I'm now going to show you how, you see, this assumption is going to be wrong when you come to, you see, at the middle of our calculation or in the final stage of our calculation. Suppose radical 2 is rational. Look, if radical 2 is rational, guys, radical 2 can be written as, you see, a lowest rational form of a over b, where b is different from 0, a and b are integers, and a and b cannot be even. Basically, what I brought here is the following. If a number is irrational, it can be written in a lowest form. For one thing, it might be given in lowest form. For another thing, if it is not, you see, in lowest form, we can obtain its equivalent lowest form. So whatever rational number is given, it can be written in a lowest form. So you have to underline that. That's why I just wrote this word lowest and this not, you see, in a blue color, because I do have something to come to these 2 points later. So if radical 2, it can be written as a over b form. So look, radical 2 can be now written as a over b. So from this, what follows is a is b times radical 2, just applying crisscross multiplication. Then square both sides, guys. See, square both sides. Then a square comes to be 2 times b squared, because number radical as you are squaring. So a square equals to b square, and we know that, you see, if the square of a number is even, the number is even. So a square is even implied that a is even, because we can take the contrapositive of this one. If a number is odd, its square is odd. And if you take the contrapositive of the one I raised now, to be like this. If a square is not odd, that is, if a square is even, you see, a is even. So a is even. What happens if a is even? If a is even, a can be written as a multiple of 2 for some natural number k. So a is 2k. Now guys, look, we can directly substitute this one. A is equal to 2k directly. Where? Here. We need to square this one. So it will be 2k times 2k. It's going to be 4k squared. You see? Look, it is going to be 4k squared is equal to 2b squared. What I did is, I simply substituted the value of a, that is 2 times k, here in place of a, that's all, and squared it. This is going to be 4k squared equals to b squared. This is directly taken from this one. Now here, you see, we can cancel, you see, this by 2. So divide both sides by 2. Then one can get that b squared is the same as 2k squared. Look again, b squared is a multiple of 2. If b squared is a multiple of 2, as we said earlier in the case of a squared, b squared is again even. And if b squared is even, by applying same assumption as we did over here, b is even. Now look, at the beginning we said that a over b is a lowest or a simplified lowest expression rational form. But now we obtain here that a is even and b is also even. What are you saying? This is, you see, this contradicts with the idea that a certain rational number exists without being in lowest form, being numerator and denominator even. How dare we can have this? You see, we might have rational expressions basically which are not in lowest form, having, you see, even expressions in both numerators as well as denominators. But as I tried to explain, we can convert these to lowest form. But what we are saying here is there is a rational number, you see, having even values in both the numerator and the denominator without being what? Changed to lowest form. And this is a contradiction. Hence, a contradiction comes. And this contradiction comes because of the fact that, you see, at the beginning we have assumed that radical 2 is rational. You see? So we regret now and say that radical 2 is irrational, okay? So in such a way we can assure that radical 2 is an irrational number.